Corneal crosslinking with Flavin. Understanding keratoconus. Collagen is a kind of protein that is responsible for providing structural support to tissues and in the cornea. It is present in the stromal layer. Collagen gives the cornea its strength, elasticity, and form. Keratoconus is a disorder of the eye which results in progressive thinning of the cornea. This may result in blurry vision, double vision, nearsightedness, astigmatism, and light sensitivity. No definite reason for keratoconus has been traced so far. Possible reasons for keratoconus are imbalance of enzymes within the cornea, heredity, overexposure to UV rays, excessive eye rubbing, poorly fitted contact lenses, and chronic eye irritation. Corneal refractive procedures, such as PRK or LASIK, can also result in ectasia, where after the procedure, if the remaining corneal tissue is not strong enough to sustain the intraocular pressure, which gives it a shape, the cornea can bulge forward and becomes progressively thinner. Symptoms of keratoconus: progressive nearsightedness, development of irregular astigmatism, distorted and blurred vision, glare and halos, frequent changes in eyeglass prescription. Keratoconus can affect both eyes generally, but sometimes one eye also. Degree or magnitude in both eyes, not necessarily the same. This change can stop at any time or continue for several years. In more advanced cases, the cornea may be scarred, and in worst cases, one can get a localized rupture of the cornea called corneal hydrops. Keratoconus can be diagnosed by vision test and using equipments like retinoscope, keratometer, corneal topographer, and/or slit lamp biomicroscope. What is corneal collagen crosslinking? Corneal collagen crosslinking, also known as CXL, is a procedure to crosslink or bond the fibers more tightly within the cornea to stop the progression of keratoconus. It can be used in cases of keratoconus as well as corneal ectasia. The procedure involves applying drops of Flavin, which is riboflavin, a form of vitamin B2, until the corneal layers are deeply saturated. The central 9 mm corneal epithelium is removed before Flavin is applied. It is also known as epi-off technique. Once the cornea is saturated with Flavin, the cornea is exposed to ultraviolet light using corneal crosslinking equipment. The time of exposure varies from 5 minutes up to 30 minutes, depending upon the energy used in corneal crosslinking equipment. During the process, Flavin acts as a shield against the penetration of UVA rays and underlying tissues. Flavin works as a photosensitizer, and in presence of UVA light, it gets activated and induces the cross-linking between collagen fibrils, resulting in strengthening of the cornea. This can stop the progression of keratoconus or post-refractive ectasia. In 1-year results, CXL procedure showed success in halting keratoconus progression in more than 90% of treated eyes, with more than 45% of eyes also gaining slight improvement in corneal shape. Vision was better after treatment than before in about 50% of eyes treated with CXL. In case of stabilized keratoconus, phakic lenses also can be implanted to gain better and optimal vision. Sometimes, corneal cross-linking procedures can be performed along with or after LASIK or intrastromal corneal ring segment to improve vision and/or corneal stability. Although corneal cross-linking procedure typically does not restore vision totally, it may improve uncorrected and best spectacle-corrected vision after the procedure. Corneal cross-linking with Flavin increases corneal strength and stops progression of keratoconus.